Now, again, to remember that currently I have taken in a most basic scenario. So there's just one lane. There's, of course, a straight road. There is just one lane. And that might be just bugging out you all because that's too simple to take. Now, let's imagine what's a multi lane. One way to say that is if there's a multiple lane, so that's lane number one, and that is lane number two. For the Indians, when you see things like this, it has a meaning. So it's a dotted line, so you can, that's one lane, that's the second lane. You can either travel here or you can travel here, but you cannot travel like this. In India, it's allowed not by traffic rules but by best practices. We don't follow the lane discipline. And there's actually a reason why we don't follow the lane discipline, because everything has a bandwidth. So we also discuss bandwidth. In India, for a two-lane road, we can actually have four vehicles. We include the payments as well. So a bandwidth increases, and a bandwidth increases because in two-lane road we have four vehicles. That's nowhere else possible because two-lane road means two proper vehicles which consume the entire width. Now, most of our vehicles are motorbikes. They are too short for a complete lane, and we've got manually driven rickshaws, which are again too small for the entire width of the road. We've got lots of bicycles. We've got all these smaller vehicles, so we can actually fit in a lot of vehicles, and that's why in India we rarely follow the lane discipline. In many cases, it can lead to a better traffic bandwidth than available anywhere else. While the Western world is, of course, the proper cars where the width of the vehicle is almost the width of the lane, so the lane discipline is to be followed. Of course, there are trade-offs as well in India. If we, I mean, the bandwidth, of course, in ideal cases can increase because of the width of the vehicle, but so does the uncertainties, and hence the not following the lane discipline and the traffic rules is actually pretty much a severe hazard. You really don't know when somebody cuts in or cuts out. They can travel in between of the lanes, and just because people can travel in between of the lanes, remember density. So we have a lot more density than what is allowable, and we operate at the congested level. And now you know what will happen when we do that. So because lane discipline is not followed, there's more reason to be congested. So anyways, this simulation is not for Indian traffic conditions where there is no lane discipline. This is where there is lane discipline up. So if you ideally simulate that up, there's no reason why this should be different from a previous model. I think I did not say that. This one is called as the intelligent driver model. So there's no reason to believe that it'll be a different intelligent driver model. So simulation of this will use this as input, and simulation of this will use this as input. So you can actually follow two lanes. The model is scalable. You can, instead of one, you can follow intelligent driver model for all the vehicles. Now the only thing that changes around over here when you have got two lanes like this instead of one is that sometimes the vehicles may like to change lanes. So let's draw the same scenario again and say what is the genesis of changing the lane. So let me give you one example where changing lane makes a lot of sense. So the distance is small, the distance is large. So if I change lane, you know that larger the distance, I'll be able to operate at higher the speed. So lane change makes a change difference. But then what if this is a very slow vehicle and this is a very fast vehicle? Then lane change doesn't make a distance. So in general, I take two inputs. The first is that if I get more space gap, then I change lane. If I get significantly more space gap, I change lanes. And secondly, if I get in behind a vehicle which is moving faster, then I change lanes. So the general rule is called as the utility of a lane is given by the time to collision. The time to collision is, so that's a space gap. This is my preferred speed, not my current speed. This is the speed of the vehicle in front. So let's calculate it for both of them. So utility of lane 1 So if utility of lane 2 is significantly better than utility of lane 1, lane change will take place. So time to collision is my general metric. So I decide how good is a lane depending upon time to collision. And remember that time to collision could be negative, which is practically finite. So the vehicle in front is traveling at 60 km per hour. I can maximum drive at 40 km per hour. Collision will never happen. Time to collision is infinity. By this formula, it's negative. So I say if I'm at this lane, that's my time to collision. If I'm that lane, that's my time to collision. If I'm at that lane, that's my time to collision. And then I'll decide whether to change lane or not to change lane. And that's why many transportation departments have different lanes at different speed limits. So you decide what's your speed limit and then you choose accordingly. Now, the caveat is that if you drive at a lane whose speed limit is between 40 to 60 km per hour, you cannot travel lesser than 40 km per hour. Because if you travel lesser than 40 km per hour, then it's not good for the people who are traveling behind. So that's why transportation department divide all the lanes into speed zones. So you decide your speed and you go on that, and then your time to collision is infinite. Because if you want to travel at a higher speed, you go on to the next lane. So time to collision is always infinite, or you're always at a lane which has the best utility. In general, for general traffic, you say what's my time to collision. So that's when you are not traveling at your preferred speed because there's a vehicle in front, either the distance is too low or the speed of the vehicle in front is too low, and that's why it's not facilitating a large speed of yours. So then there's a loss. Then you say at this lane, what is my utility? At the next lane, what's my utility? You say that, okay, if it's significantly better. Now remember, lane change is an extremely difficult maneuver. So many people are lazy enough, they don't want to just change lanes. So if it's significantly better, then only it will happen. Otherwise, you'll keep on changing lanes like a greedy person. Sometimes you stand in line for the airport. You like, okay, there are lesser people, you go there. But then, okay, here also there are less people, and you go there, and you are continuously shifting. So to avoid this continuous lane change, you say that even only when it's significantly better, then you absolutely change lane. Now, so far we were saying that there's only a linear speed, there's no angular speed. Now an element of angular speed comes in. And how do I really do that? That becomes interesting. Now, it really turns out that lane change is a very easy maneuver for the vehicle. So from the localization system, you always know your position. You need to lane change. There's a vehicle over here. You need to avoid it up. This is your vehicle. You need to lane change. So you say this is where you anticipate your position to be. This is a predefined trajectory that is adapted as per the position and speed of this vehicle. So basically, it's like predefined curve that has an energy function, and the curve takes in a shape so as to have a minimum energy function. In short, it's a predefined trajectory that's adaptive based on this thing. So if this vehicle would have been here, the shape would have been pretty much like this. If this vehicle would have been here, the shape would have been pretty much like this. So the different phases from which this shape goes to, that is what you define based on how far, how near it is, and similarly based on at what speed is the vehicle in front traveling. That's also something that you consider as an input when deciding how to really go. That's what is a lane change, and lane change leads to something which is pretty interesting. So it leads to something which is absolutely interesting, and let's look at that. Now imagine if this is the scenario, and there's a slow moving vehicle over here, that's a slow moving, you are a fast moving vehicle, so of course you will lane change, and sometimes you get back over here. So this is what's called as an overtaking. It was a dashed line, that means I could have come over here. Sometimes they are overtaking zones, so let's go overtaking zone, so I can temporarily occupy this lane. If it's the other way, then it's for the other person, so that's an overtaking zone, so I can just quickly chip in over here and quickly chip out over here. So that's what's an overtaking zone. This road may be for these vehicles, and I may just look at the vehicle in front and say there's enough distance over here. In India, of course, we do it without overtaking zones. We do extremely risky overtakes. But then again, the problem with India is exactly the same thing. Everywhere in the world, what's the speed range? People will drive between 60 kilometer per hour to 80 kilometer per hour, so the speed range is very small. We've got very slow vehicles, we've got very fast vehicles, so we've gotten people who would like to drive at 120 kilometer per hour, those SUVs. We've got people who drive bikes at maximum of 60 kilometer per hour. We've got people who are driving the slower scooties and all at 30 kilometer per hour. We've got people driving bicycles at 10 kilometer per hour. We've got people who would like to just walk on the road and there's no pavement. So our speed variation is so large, so overtaking becomes absolutely mandatory. If you don't overtake, it is like the entire transportation efficiency would come down. That's why we need to take in, irrespective of the traffic rules, all the overtakings need to happen. And that's why what only happens in India, that there's a vehicle behind, there's a vehicle in front, and this vehicle will almost go into the pavement to facilitate this overtaking, because if it doesn't do that, and 20 kilometer per hour, a nice SUV is chasing a three-wheeled auto rickshaw, which is driving at 20 kilometer per hour, and then everybody's like, what the hell, is this transportation system a joke? So in India, all overtakings need to compulsorily happen for transportation efficiency, and people do the utmost that they can by driving at the. And remember that the width of the vehicle is not fixed. From small width to large width, we have absolutely every array, and that's why the overtaking rules in India also don't really exist, because it's mandatory. It's like the emergency vehicles in the Western world. So the ambulances need to overtake irrespective of rules, and people do everything. In India, it's like all are ambulances. So every overtaking must happen, and the rules as per the local contextual knowledge need to be bended, and all cooperation need to be followed to accommodate that happening. But then, of course, our simulation is for more or less a system where there are lane rules, there are overtaking zones, and only between that is something that happens. Now, in overtaking, there are two things important. The firstly, I mean, what's the need or utility of overtaking? That's of course based on the difference in speeds and the distance. And secondly, what's the feasibility of it? And once you say that it's a feasibility of it, it's again a predefined trajectory. So it's just a two-lane change trajectory. So overtaking will always have three parts. The first part is what is the overtaking lane change, as discussed previously. So this is overtaking, and this is finishing overtaking. So based on vehicles at this lane, and based on vehicles at this lane you decide what is the feasibility of overtaking. And if the so I mean that could be simple mathematical formulas based on distances that you need to move, and then you again design, I mean, adapt the speed defying trajectory based on energy function or something that takes you into the overtaking trajectory. And once you go into the overtaking trajectory, you just overtake it up and you complete that up. So that's the other thing that happens.